Okay, now in this section we'll continue with our discussion on the difference between hub and a switch. Like in the previous video, we have seen the major difference between the hub and switches. It will always do broadcast, and whereas switches do broadcast initially and later on it will do unicast. Now there is one more difference between hub and switch. There is something called broadcast domain, collision domain. So let us first try to understand what is broadcast domain and collision domain, and then we'll come back again the difference between them, difference between in the hub and the switch. So the broadcast domain means set of devices receiving the broadcast originated by any one of the device within the set. Now if I take an example, I got a very big network. I got some switches here. Now there is one device connected here is generating a broadcast. Now switches do broadcast for the first time if they don't know the destination MAC address. Now what the switch is going to do? Switch is going to send out of all the ports. Also it will send on the port which is connecting between switch to switch, because when you have a very big network, it will go to that particular port and then it will forward to all the ports. Also it will send to this port here as well. It will go to all the ports here and it will send on this port, and then it will go to all the ports here and it will come back here and it will go to all the ports. Also it will go on this port. So broadcast is something originated by any one device. It will send to all the remaining ports, and the router will not propagate the broadcast from one side to other side. So router says if it receives any broadcast, it's going to stop, whereas the switches, if they receive any broadcast, they will automatically propagate to all the remaining devices, all the remaining ports, whereas if the router receives any broadcast, it is not going to propagate to other ports. Router simply stop the broadcast. Now the broadcast message is originated here, any one device, and it is going to all the devices in the LAN, and this is what we call as domain. Domain is like boundary, and how long your broadcast is going to do, that is what broadcast domain. So set of devices, set of all the devices receiving the broadcast, friends. So which means each and every device here connected in all the 4 switches, they all receive the broadcast, and it is originated by any one device within the network. So just like every one LAN will be recognized as one broadcast domain. So understanding this broadcast domain concept is very important if you want to understand the advanced switching concept like VLANs. That is something we'll be seeing more in detail in the advanced advanced switching concepts. But when you talk about LAN, if I have 200 devices connected in the LAN, let's say, take an example. If any one device generates a broadcast, the broadcast goes to remaining 199 devices. If I have 500 devices connected in the LAN, one device generates a broadcast, the broadcast goes to remaining all 499 devices. That is what. So you might be connecting 10 switches, 20 switches, it doesn't matter. But every LAN will be considered as one broadcast domain. So, and every LAN segment, here you can see this is one LAN, one broadcast domain. This is one LAN, one broadcast domain. Okay. So if you just take an example here, if you just try to figure out how many broadcast domains here we have. So if any one device generates a broadcast, this is one broadcast domain because this is one LAN, and this is another LAN, and this is another LAN. So totally we got 3 broadcast domains, and if any device generates a broadcast here, it will go within this particular LAN because the routers will not propagate to other LANs here. So this type of questions you can expect in your examinations, where you will be given a set of diagrams and you will be asked on how many broadcast domains you have and how many collision domains. The next thing we need to understand, let's try to understand something called collision domain. The collision domain is something we call them as set of devices sharing the broadcast in the network segment, sharing the bandwidth or sharing the where there's a possibility of collision. Before we actually get into collision domain, let's try to understand a concept of CSMA-CD, carrier sense multiple access collision detection. Now what exactly it says is, now take an example, I got a network segment here which is connected in the LAN, and I'm connecting to a switch or a hub or any device we can say. So now we are connecting to a centralized device called a switch, star topology, but logically it works like a centralized location where you are connecting. Now the basic concept of the CSMA-CD here is It is the actual carrier transmission method which is used in the Ethernet networks. Now it is helps in collision detection and collision avoidance. Let's try to understand. Let's take an example. There is a device who wants to send the information here, trying to send the information, and this device want to communicate with this device. So I want to communicate with this device here. Now this device is sending the information. So before it sends, it is going to sense. That's what we call as carrier sense, where it will sense whether any other device is sending the data or not, sending the traffic or not. Just like before you cross the road, you will try to you will ensure that there is no any vehicle is moving or not. So if there is something going on, probably you will stop and you will let them go, and then you will cross the road. So it's more like that. It's going to sense. That's what you can see, carrier sense. Why it is doing that? Because there is a multiple access, multiple devices are accessing the same media or the same cable or the same backbone switch, because there is only one road here. That's what collision domain we call it as. I'll come back on the collision domain. So why it is doing that? Because to detect the collisions, to avoid the collisions. Now once any other device is not sending the information, then it will start sending the information. And while it is sending the information, if any other device also want to send, maybe want to go to here, so it will sense that there is already other devices sending the data. So it will stop and it will wait of some time, and then it will finish the sending the data. Then the other device will start sending the data. Mostly after some time, then it will start. Now this is what we call as carrier sense multiple access collision detection. Therefore carrier sense multiple access collision detection. Now this is the basic Ethernet concept of sending the information on your Ethernet networks. Now do you think the collision will not happen in these cases? Now still the collisions do occur in these scenarios where let's say both the devices sense there is no one is sending the information, and both senses that and both sense at the same time. Then there is a possibility of collision. There's a possibility of collision here. Why? Because there is only one road shared by all. Now we can compare this collision domain as one road or one common network segment. So one network segment in technical terms we can say as one collision domain. So in case of hubs, there is only one collision domain. If you just take an example here, I got a hub device here. This is my hub which is connecting, and in the hub there is only one collision domain, which means there is only one network segment sharing the bandwidth, and there is a sharing of bandwidth, which means two devices cannot send at the same time. They should send one by one at a time. They cannot send at a time. So if they do that, there is a possibility of collision. And then whereas if in case of switches, you have a separate collision domain for each and every port, which means every port is a separate collision domain. Every port is just like a separate network segment, and there is no sharing of bandwidth, and each and every port is having a dedicated bandwidth. So if I say 100 Mbps port, I can send and receive at a speed of 100 Mbps. And every port is having a separate road, and they can send and receive at the same time, and there is no collisions occurs in the switches because every port is having a separate collision domain. But whereas here there is only one collision domain, means only one common network segment for all. Now this is one of the major difference in the hub and the switches that makes our hubs not much used in today's production networks. Okay, so that's a major difference. If you just come back, so understanding broadcast domain and collision domain is really important for you to know the behavior of hub and the switches. In the switches, by default, there's only one broadcast domain. Any number of switches it can be, but by default means we can make them into multiple by using the concept of VLANs. So virtual LANs, we'll be discussing that in the advanced switching concepts later on sessions. But in case of hubs, there's only one broadcast domain, and we can have only one. We cannot divide them into multiple. And in the hubs, there's only one collision domain where you have a one common network segment, and you have a shared bandwidth between all those devices, and multiple devices cannot send and receive simultaneously. And mostly hubs work based on half duplex, which means you can either send or receive but not at the same time. So whereas switches initially they were half duplex, now they do support full duplex, which means I can send and receive simultaneously at the same time. And also, every port is having a separate collision domain, which means each port is having a separate collision domain. Depends on number of ports. So this is one of the major difference between hub and a switch. So which makes switches are much more common devices used in today's production network. Now here in our CCNA contents, we are not going to use any hubs here. We are going to use only switches.